This presentation is on EBTRON measurement technologies, how it works, and what products we have to offer. We're going to talk mostly here about airflow measurement. Basically, what I'd like you to understand is how the basics behind how the product works. Make sure you understand it's not based on pressure or vortices or anything like that. It's a thermal airflow meter. And if you know the power dissipated to the airstream from a heated element, and you know the delta T, the difference between the temperature of the heated element and the ambient, then you have a relationship that's proportional to the velocity or the mass velocity. And when you look at the EBTRON product, what you have, if you look at the illustration there on the right, that's one of our probe tubes. And in each one of our sensor node locations, there's two thermistors. One is self-heated. We pass a little bit of current through to heat it up above ambient. The other one we call a zero power thermistor, which is basically a thermistor that's maintained at near ambient conditions. There's no real self-heat. And so from the two, we can get the delta T, and from the one that's heated, we can determine what the power is, and that's really the main thing that we need to know to make an airflow meter, a thermal airflow meter. What's very important with the EBTRON, differentiates us from everybody else, is this bead and glass thermistor that we use. Basically, I'm going to say bead and glass as big. There's nothing big about them. It's just a way for you to remember them, that they're an important part of our product. They're oven aged for stability. They're pretty much go through like a 4-week aging process. They're hermetically sealed for long life. They're designed to survive extreme temperatures. In fact, the part was actually developed in the 60s for NASA and the space program for the extremes and temperatures that they would see in space. They're individually calibrated at multiple temperatures. Unlike today's chip thermistors, these parts are very variable. There's a lot of advantages to them in terms of stability, but there's a real learning curve in using them, and that's one of the reasons why I think we're the only ones who actually use them, because it's kind of like a lost art or lost science of how to use a bead and glass thermistor. So we actually have to put these in the individual controlled temperature baths and get the resistance temperature characteristics. It's quite a process. We don't actually show it to anybody. It's fairly automated, but it's very unique. And then after we go through that calibration, we pot them with an advanced epoxy to protect them, the sensor leads, from water and atmospheric acids. All right, so bead and glass thermistors is the thing that you want to remember. When you look at Thermistor Stability, it's a big deal. We were fortunate enough to have our service department put some probes in the closet, and one day we dug them out, and we ended up having 10 years worth of parts in there, and we were able to take them apart and put them back into these baths and see what the resistance temperature characteristics were of these older products. And when we plotted it, what we found was the best fit line is that red line. So over a 10-year period, we had no significant change in electrical resistance versus temperature, which is the key to making a thermal airflow meter and why it's key to use the bead and glass thermistor part. You're not going to get that kind of performance out of chip thermistors. So you have drift-free performance. When you look at our competitors, you know, this is about the only thing I'm going to talk about with them. They use chip thermistors. It's an inexpensive part. It's a totally different way of doing things than we do. There you have the Ruskin part. You'll see those two chip thermistors that are basically put onto this flexible circuit that they use and then conformally coated. And then you have the air monitor unit, which also uses chip thermistors, and they don't actually self-heat their thermistor. They use a heating element. So when any of these folks come and say to you, well, it's just like an EBTRON, it clearly is not just like an EBTRON. There's quite a bit of difference. You'll have to make that decision of what you think is important. But assuming that you understand the benefits of the bead and glass thermistor that we use, I would put into your specification, if you're an engineer, each sensor node shall consist of 2 hermetically sealed bead and glass thermistors. Nobody else is doing that. If they tell you they do, they are. They just simply don't understand it, okay, that they're not doing that. Devices using chip thermistors of any type or packaging are not acceptable. I mean, that basically eliminates the Ruskin and the air monitor product. And devices using platinum wire RTDs or similar hot wire devices are not acceptable. You may run into some thermal hot wire devices that are trying to get some of your jobs. Typically speaking, hot wire is good for industrial applications because of the way it's manufactured, but honestly, I don't think it's as good of an airflow meter. When it comes down to the calibration process, We do not do the AMCA process. I'm not a big believer in it. I can tell you why if you want to give me a call. We basically believe in NIST, which is the National Institute of Standards and Technology. It's very independent. We send our calibration standard to NIST with an individual that accompanies it. They provide us with this report on calibration. If you take a look at this report of calibration, just quickly, the leftmost column there in the table is the NIST airspeed, which is based on a laser Doppler anemometer point measurement. And then the next column in is our reference, what it reads, the ratio between the two. So you see that our reference is within 0.5% or so of the NIST standard. And then the expanded uncertainty, which is nothing more than the standard deviations of the data set of the NIST readings and our readings, and that starts your traceability. And basically, it's documented accuracy. We'll do something that nobody else will do that I'm aware of. Provide a copy of the NIST calibration report for the reference standard used to calibrate the production tunnels used to calibrate individual sensor nodes. Put that in your specification because nobody else is going to do that. And then reference standards calibrated third-party NIST traceable labs are not acceptable because why add that other level of uncertainty? And devices claiming AMCA certification not acceptable. And the only thing I'll say about the AMCA stuff is you can certify one flow meter in an AMCA certified tunnel and then make claims that the rest of your product line is AMCA certified. So you'll see people say that they've tested them or whatever with the AMCA stuff, but honestly they're not calibrating and testing each individual unit. They're simply making one work very well, calibrate it, test it, create a report, say I'm AMCA certified. A little bit different than what we do. So again, what's unique to us, and maybe you'll get to do the factory tour at some of these other manufacturing facilities and get to see how they calibrate them. I don't get that tour. But basically, we calibrate each individual sensor node. Each one, not the unit as an assembly. We don't assume that the calibration of one unit can be applied to all of them. We calibrate each individual sensor node in each product that we sell. Okay, and this would be typical for a Gold Series ducted probe where we'll calibrate at 15 airflow rates between 0 and 5,000 feet per minute plus still air, so 16 points. All right, it's a very unique process. Think about that. If you have one of our EBTRON products with 16 sensor nodes in it, we've done 16 individual calibrations of those sensor nodes. All right. If I look at one of the sensor nodes and do a report of calibration, you'll find every one is well under 0.5% of reading. And so that means every EBTRON comes off the production floor within 0.5% of reading of each other. And that's where we come up with our 2% of reading sensor accuracy, okay? So very important. I would add this to the spec, but be careful that when you look at somebody else's claims, each sensor node shall be individually wind tunnel calibrated at 16 points to NIST traceable airflow standards and have an accuracy of plus or minus 2% of reading over the entire operating range. Okay, that doesn't mean that we've tested one unit at 20 points or 25 points. It means that we calibrate each sensor at 16 points to these NIST traceable standards, and we have documented accuracy. Okay, so that's how we come up with our percent of reading measurement claim. When you look at what we're doing in the field, it's really a reversal of the calibration process. Each one of these probes, if you look closely at them, you'll see that each sensor node is barcoded and serialized, and that data gets written to a one-wire memory chip in the connector, and that when you plug it into the transmitter, all that calibration data goes over, and all the transmitter is doing is reversing the calibration process. Converts the voltages to binary, and then we calculate the airflow and temperature of each point, and then average an output. It's very simple, but very independent. You have a 16 sensor node EBTRON, you effectively have 16 airflow sensors and 16 temperature sensors. All right, so it's true sensor averaging. This is something I want you to understand that you may not recognize the importance of. So we're not just an airflow meter. We also provide psychrometric values, readings, okay, measurements. So we do velocity weighted measurements. And this is going to go quick, so you may not grab this first pass, okay? But let's say we have this airstream here, and the two colors represent the fact that we have two different temperatures and we have two different velocities, okay? So The top of the airstream, where the first probe is 5,000 CFM at 80 degrees Fahrenheit, and the bottom is 3,000 CFM at 70 degrees Fahrenheit. If you simply use the average, all right, if you simply use the average temperature, you would end up getting 75 degrees on the average, but really the true average temperature is 76.3 because you have twice as much air moving at 80 degrees. You can't get that measurement with just an averaging temperature sensor. You need to know the airflows. That's very, very important and not obvious to everybody. And the bigger the temperature profile and the bigger the velocity profile, the more important this is. When we take a look at the moisture side of it, let's assume that the actual grains per pound of moisture were constant throughout this profile. But again, you'd have two different relative humidities. On the top stream, you'd have the 41.1%. The bottom, you'd have 57.5%. If you simply took the average, you'd have 48.5%. If you used the average temperature applied to the single humidity sensor, you'd have 48.5%. When the actual relative humidity is 46.5%. And that may be important, very important on some of your critical relative humidity applications. And then enthalpy is the same type of thing. If you simply just use the average temperature and a humidity sensor to calculate the enthalpy, you get 27.8 BTUs per pound. When using the weighted one, you'd actually get the true or 28.2. And it would even be worse if you just used a typical enthalpy sensor that was located in, say, the bottom of the duct there, where you can see it's 26.6 BTUs a pound. That's very important when you make the decision to go into economizer. And on economizer switchover, you don't want to be economizing when you shouldn't be, or vice versa. The other thing that's real important with us, I think, is what we call sensor node ruggedness. I mean, we've been around for a long time. I think we've gone to the College of Hard Knocks in that time. And we learned that outdoor air intakes in particular are not clean. And so there's a lot of exposure to salts, and there's a lot of exposure to atmospheric acids, a lot of sulfur dioxide in the atmosphere. And we learned the hard way over the years that you could get corrosion of the sensors. So what we've basically done is we've tested our products in heavy saltwater baths, as well as exposure over fuming acid baths, much more than you'd ever see in the field. And then once we did that, we said, well, we should really go out and have this reproduced by an independent lab so we can make this a spec item, because a lot of our competitors wouldn't be able to handle this. So we suggest that you require this. Thermistors shall be, whether you say thermistors shall be potted in engineering thermoplastic assembly, that is definitely key to us using waterproof marine epoxy. But the thing that's the most important here is it shall not be damaged by moisture, direct contact with water, or exposure to atmospheric acids, and provide a copy of an independent laboratory report to verify compliance with this requirement. Okay, we do a lot of things that our competitors don't do, all right, because we want to make sure you have long-term performance of our equipment. So we're saltwater and chemical resistant, and this is actually a picture of the saltwater immersion test that we do on the sensors. It's not like we just spray them with a light salt spray. They're immersed in heavy saltwater baths. Construction excellence, I think that's what we're known for. Among the fact that the other thing that we're known for is our test equipment and how we test and calibrate. But construction excellence, you can see. All right, so we talked about the beaten glass thermistors, and we talked about the potting. But what we didn't talk about is the fact that all the internal wire is Kynar coated instead of PVC coated or PVC jacketed. And the reason for that is over time, we know that these wires will vibrate, and over time, a PVC jacketed wire will end up wearing through and eventually shorting out to the tube. Okay, so we just use Kynar to start with. We use a very strong aluminum tube, the 6063 T6. They're all gold anodized. Basically, this may be a little overkill, but we use 304 stainless steel mounting brackets. This is very important on the cable. I've heard our competitors say it's a disadvantage that we have a cable. I'll never understand that. having to buy an external cable, make an external cable, or have to deal with the jacketing on external cables, to me is never a good idea. I mean, we make a very durable cable. We use FEP jacketing, which is basically a Teflon derivative jacket. Compared to PVC, when you get into real cold environments or UV exposure, PVC will just crack and open up. FEP jacketed cable won't do that. It's something we feel is very important. We also use these positive locking cable plugs, and on the gold product, they're actually all gold plated pins, which is great for interconnects when you do gold plating. It's a no compromise construction, and that's the way we do business. In our product solutions, I'm going to go through this quickly. On product comparisons, we have our gold series. Basically, we've gone to this easy to read dual line backlit display. We have really unsurpassed connectivity options. We provide isolated outputs. We have RS-45 BACnet and Modbus, Ethernet and LAN network solutions. We provide you with, on the Gold series, a free Eblink low energy Bluetooth interface for Android and iOS devices. If you don't want that, we can provide it without the radio, but it is provided on the product unless you specify that you don't want it. All of the connector pins, as I said, are gold plated. Everything is gold plated, all connections, interconnects. When you look at the Advantage 4 Hybrid Series and EBFlow, which are our other products, they're a little bit lesser products, single line, non-backlit display on both. The connectivity options are less. It's either analog or RS-45. And the signal isolation is achieved via onboard isolation transformer on the hybrid, or with your external power transformer on the EBFlow 2. It's really not that much of a disadvantage, but it's certainly not the same as the Gold series. When we take a look at the Gold series transmitter, again, this is kind of recent. We've gone to this GTX 116E or GTX 108E if it's the fan units. And it's this two-line backlit display. We've replaced our slide-up cover with a hinged cover. But on these probes, they're now available with a relative humidity sensor, which can provide you with weighted humidity, weighted enthalpy, or dew point, which is a big advantage. I think I see real opportunities there to use these products for economizer switchover. I also see reasons and advantages to use this product for supplier humidity control. So you have some real opportunities here to, it's just another level up on the EBTRON product. It's not just an airflow meter. Don't forget that, all right? If we look at the product lines, we're just going to do this quickly. We talked about the Gold series and the Hybrid series. On the Gold series, it's either a PC density or a P plus density. They're both the same number of sensors. It just has to do with how many probes there are. Okay, so the Gold series has the highest sensor density arrangement. The Hybrid, effectively, it's using the same sensors. It calculates airflow the same way, but it can only have 4 sensors instead of 16 like the Gold. All right. So for whatever it's worth, that's what the real difference is. The Gold series has typically the best out-of-the-box installed accuracy, and that's the product you typically want to use. When we get into outdoor air intakes, guess what? It's the same products. I just put it here because people feel better if I tell them that, well, it's for outdoor air intakes. All right, so we're just showing that the same products. My personal opinion is you really want to use the Gold series in outdoor air intakes. There's so much going on in an intake, you need as many sensors as you can get to get a reasonable measurement. We have this Air IQ2 that we work with TAMCO on. It's designed specifically for outdoor air intakes for people that are looking for a package solution. Basically, there's 2 versions of it. There's the Air IQ and the Air IQ2. And actually what we found is the Air IQ2 is for your outdoor air intakes. The Air IQ had a lot of applications also, the original one, for unducted returns or exhaust fans. And because of this 3-inch radius flare, and it's a little bit wider than the Air IQ2, we've made a decision to keep that product for those applications. When we get into the Eblink is fantastic. I mean, we don't charge for it, and it gives you the ability to walk into a room and see what the EBTRON's reading without going up on a ladder or wherever the transmitter enclosure is located, which gives you the ability to not worry about where you put the enclosure actually. And it'll give you the airflow and the temperature, and if you had relative humidity, it'll show you that and the other psychrometric values. We call that the live data screen. The traverse data screen will give you the individual sensor node airflows and temperatures. And then we have a diagnostic screen that'll do everything that our diagnostic mode will do. Give you all the configuration parameters that you've set it to, show you individual sensor voltages, sensor temperatures in real time. It also has a send to EBTRON service button, so that if you're having a problem, you just send this data to EBTRON and it will facilitate any of your service issues. I think it's a really great product, and I think it's very valuable. The one thing I do want to say to you is when you order it, make sure that you give us a location name up to 16 characters, because if you give us a location name at time of order, when you walk in the room with this EBLink app, it'll show you, like this one says AHU5 return air there on that top left screen. That was a name that was provided at the time of order. The other thing that's really good about it is sometimes we've talked about in other presentations where folks will adjust our flow meter, and you want to go see what the flow meter really read if they did do that adjustment. You can't really disable it, or you shouldn't really disable it at the transmitter, because if you do and the system was control system was kind of tweaked to work with these corrections they gave them, you could really screw your building up. So you use the EBLink reader and you just turn flow adjustment off, and you'll see the unadjusted airflow rates. And the thing that's nice about it is, again, from a user's perspective, it's a read-only device. We originally had designed it to be a read-write device until we realized that write capability, anybody who had the application could get in and potentially hack your system. And even with password protection and things like that, we just decided it wasn't worth it. So it can't write. It's just a read-only device, okay? Application specific, the products there, that's where our EBFlow 2 product line works out. We have basically 2 airflow measuring probe types. One we call the -U, which is a universal probe type. The other is a -T, which is a terminal box probe type, okay? So the U, you can adjust. It's really great for really small rooftop units, like under 10 tons. It works out very well on desiccant wheel type energy recovery ventilators. You just mount it downstream of the wheel. The transmitter itself actually can be configured for dual outputs in that energy recovery application, so you can get intake and exhaust off of a single device. When we get into the terminal box, we're talking about round ducts. It's 4 to 16-inch rounds is really the range it was designed for. So it's terminal box applications, it's your DOAS applications, it could be small tracking applications. In that model, it's either available with the remote transmitter like the U probes are, or with the electronics on the end of the probe, which is our EFX 1000-T, but most of you know it as the ELF if you've used it. When we get into fans, it's basically the same gold and hybrid transmitter options. Basically when we get into single and dual inlet fans, we have adjustable fan mounting brackets, simplifies your installation. This is one case where there's not much difference between the gold and the hybrid except connectivity and EBLink, okay? So you have to really think about what you need there. The fan arrays is a gold series product. It's great. You can basically monitor up to 8 fans individually with this product, but the output is the total output of the fan. So it's good for fan arrays. And it's actually great for fan arrays, and it's very cost effective on fan arrays. Fan IQ is basically our fan inlet sensor combined with a TAMCO backdraft damper. Same EBLink on the Gold series, we just have added one more screen, which is the fan array data, which shows you the individual fan airflow rates. Occupancy, we have the CENSus product line. Basically, we have it's a really good product, and not enough people have really taken on to it, and I don't really understand it. It's a bidirectional occupancy counter for interior openings. It has two outputs. It has an analog output and RS-45 backnet Modbus connection. I actually like using it with the RS-45. I think it makes more sense. It has little features to help out in terms of falsing over time. Auto zero, meaning if it doesn't see activity, it can reset to zero. No negatives. If you have it on a single door, you don't want it. You can't have negative one person on a room with one door, so don't ever let it go there. If you just put it on an opening and just walk through an opening without a door, it's going to be better than 2%. It's not going to false at all, actually, and up to 42 inches wide. And if you have a door, it adds a little more, complication because you're moving through opening and closing a door. We say you typically get a 5% accuracy. And the fact of the matter is you could put it on wider doors. You could put it on double entry doors. Just keep in mind if two people walk through that door at the same time, it may not pick up two people. It may just count you as one person. So that's the thing. But if you've been involved with my presentations on DCV, you realize that, hey, this is really a good way to do DCV. All right, that is a quick version of this. So, thanks very much for the time. If you have any questions, even though I have Ask Dave at engineeredsalescorp.com, I think when it comes down to products, this is when you ask your rep, and your rep has access to our folks at EBTRON, our inside sales group, and the people at ESC. So hopefully this was of benefit to you, and I'll see you next time. Thanks.